Previous project had a problem of wire everywhere that got me thinking what could be added in this to make it wireless. Our mobile devices are wireless, right? We can transfer data from one side to another side via Bluetooth or Wi-Fi. Both works at a particular frequency and band. So the controller we used earlier was Arduino, that is most easily available module in the market. We found it to be SC05 Bluetooth module. Actually seeing this module made me felt like I'm a Morse code engineer. First time transmitting the data, dots and space, but the task came up to make it at least run, to make them communicate. We have to dive into depth what it requires, how they talk. So let us start our journey of making the water level indicator wireless. Just a recap, we started on this journey to measure water level using various ways. We worked with diode based measurement, but that did not work out because it only works as discrete measurement. And with so many wires, most of the time went in handling the wires itself. As you know, when you are stuck, ideas do come up after a sip of coffee. Ultrasonic came to our rescue for measurement. Here is the video showcasing that. Enjoy. Earlier, we filled the water in the bucket slowly and water level can be clearly seen in the LED display connected to it. Okay, since you are updated now with the previous demonstration, let us make this wireless. So for all things, we require one more Arduino module to behave as receiver or transmitter with the previous Arduino. That's why we purchased another Arduino and a Bluetooth module. We require two SC05 Bluetooth modules. Why is it stuck? Why is it not coming out? Finally, one important thing, since Arduino works on plus 5 volt supply and Bluetooth works on plus 3.3 volt supply, on the Arduino board, we have supply pins of plus 5 volt and plus 3.3 volt. We will be connecting plus 3.3 volt supply to Bluetooth module. For Bluetooth RX, we connected a voltage divider shifting plus 5 volt signal to plus 3.3 volt signal with 1 kilo ohm and 2 kilo ohm resistors. Since input high of Arduino has to be greater than 0.6 time VCC, that is plus 3 volt, connecting directly Bluetooth TX to Arduino RX works. Let's hop on to the connections on breadboard. After it's done, we are left with powering up Arduino. Since you can see LED continuously blinking, it shows that Bluetooth module is not paired with anyone. Let us try to pair it with the mobile. Usually the pair key involved is either 1234 or 0000. After entering the key, we can see in this application when we try to connect. LED in Bluetooth module start blinking differently. Keep watching. See it changed. It blinks for 2 times, thereafter 1 second delay and then again blinks for 2 times. It shows that our Bluetooth module and mobile is paired up. We wrote the basic code for running the Bluetooth module with Arduino. For full code download, you can check out the blog where we have updated the whole code. Link is provided in the video description. Since we are using pin 2 and 3 of Arduino, an additional library software serial.h is used to configure pin 2 and 3 as RX and TX pins. Make sure RX and TX pins defined are correct. Many times we had put different numbers in different dispatch of the Arduino program, causing us a lot of waste of time trying to figure out why it was not working. Similar to the way we write serial.print, a function config.bt is initialized with the software serial library. But when we uploaded this code, nothing was getting printed on the mobile application. Headache. Figuring out the problem, we found that RX and TX pins on Arduino were interchanged. Silly mistake. Replacing with the correct connection, our module gives a thumbs up saying RLC Pro Labs. Connection has been established. This was the second debugging issue we faced while communicating. Now it is time to add one more Bluetooth module so that they can communicate with each other. Same connections with another Arduino needs to be done to power it up, that is 2 Arduinos and 2 Bluetooth modules on separate breadboards. It was easy when we integrated Bluetooth and Android earlier, but now there are some changes that needs to be done to make sure one Bluetooth works as master and one as slave. For that, a few changes are needed in the configuration, that is C mode, roll, UART and bind. Make sure to set the baud rate to 38400. At last, for direct connection with master Bluetooth, we fed its address to slave Bluetooth. Doing the same thing in programming, make sure to run the Bluetooth module in AT configuration mode by pressing down the button on module while powering it up. Address of the master device can be found out from AT mode typing AT plus ADDR question mark. This time LED blinks one time per second. After that, basic serial communication can be done. We added all the commands in master and slave Bluetooth. Let's hook them up and see whether it works or not. Once they got paired up, LED blinked in the same way as it was blinking earlier. After configuring them with the AT commands, we uploaded the basic master and slave codes where master sends the data and slave Bluetooth receives it. Keep the COM port selection in mind because we are working with the same computer. If you want a step-by-step explanation of the codes that we used, you can check out our blog. Finally, let's measure the water level by hooking up the ultrasonic and LED display just like we did in the previous project. Now the fun part starts. The ultrasonic sensor is sending data to Arduino, which has master Bluetooth connected to it. This master Bluetooth is communicating with the slave Bluetooth and data is being displayed on 16:2 LED. Both Arduinos have been programmed just like the way we explained. As the water level is filled up, we are getting the message onto the LED display wirelessly. We programmed a condition that if the water level going above 70%, one buzzer will blow. You can program such condition according to your choice. We think there could be other things that could be added up. What if we have Android application directly telling us how much water is filled? That would be cool. Keep tuned for the next update in this project soon. We have updated all the programs and detailed step process in the blog link which is provided in this description. Please like, share and subscribe our channel. We will build full end-to-end of this project together. For previous project, kindly check out our channel.